real-world entities, events, and scenes in a logical underpinning, such as a description logic, and typically implemented in the web ontology language. The meaning of description logic concepts and roles is defined by their model theory semantics, which are based on interpretations. The concepts, properties, and relationships defined in OWL ontologies can be deployed directly in the website markup as RDFA, HTML5 microdata, or JSON-LD, in graph databases as RDF triples or quads, and dereferenced in LOD datasets. Programming languages. Semantics of programming languages and other languages is an important issue, an area of study in computer science. Like the syntax of a language, its semantics can be defined exactly. For instance, the following statements use different syntaxes but cause the same instructions to be executed, namely, perform an arithmetical addition of y to x and store the result in a variable called x statement. Then programming languages: x plus equals y, C, C++, C#, Java, JavaScript, Python, Ruby, etc. $x plus equals $y, Perl, PHP, x equals x plus y, Ada, Algol, Algol 68, BCPL, Dylan, Eiffel, Modula 2, Oberon, OCaml, Object, Pascal, Delphi, Pascal, SETL, Simula, Smalltalk, Standard ML, VHDL, etc. MOVEAX, Y, AD, X, EAX. Assembly languages: Intel 8086, LDRR2, Y, LDRR3, X, AD, R3, R3, R2, STRR3, X. Assembly languages: ARMlet, X equals X plus Y basic, early X equals X plus Y basic, most dialects, Fortran, MATLAB, Lewis at X equals X plus Y, Cache object script ADDY to X, ABAP add Y to X giving X, COBOL set, AX equals %X %+%Y %batch, INCFXY, Common Lisp, XY add, def postscript Y at X plus. Fourth, various ways have been developed to describe the semantics of programming languages, formally building on mathematical logic. Operational semantics: the meaning of a construct is specified by the computation it induces when it is executed on a machine. In particular, it is of interest how the effect of a computation is produced. Denotational semantics: meanings are modeled by mathematical objects that represent the effect of executing the constructs. Thus, only the effect is of interest, not how it is obtained. Axiomatic semantics: specific properties of the effect of executing the constructs are expressed as assertions. Thus, there may be aspects of the executions that are ignored. Semantic models: the semantic web refers to the extension of the World Wide Web via embedding added semantic metadata using semantic data modeling techniques such as resource description framework, RDF, and web ontology language, OWL. On the semantic web, terms such as semantic network and semantic data model are used to describe particular types of data model characterized by the use of directed graphs in which the vertices denote concepts or entities in the world and their properties, and the arcs denote relationships between themes. These can formally be described as description logic concepts and roles, which correspond to OWL classes and properties. Psychology and psychology: semantic memory is memory for meaning. In other words, the aspect of memory that preserves only the gist, the general significance, of remembered experience, while episodic memory is memory for the ephemeral details, the individual features, or the unique particulars of experience. The term episodic memory was introduced by Tulving and Schachter in the context of declarative memory, which involved simple association of factual or objective information concerning its object. Word meaning is measured by the company they keep, i.e., the relationships among words themselves in a semantic network. The memories may be transferred intergenerationally or isolated in one generation due to a cultural disruption. Different generations may have different experiences at similar points in their own timelines. This may then create a vertically heterogeneous semantic net for certain words in an otherwise homogeneous culture. In a network created by get people analyzing their understanding of the word, such as WordNet, the links and decomposition structures of the network are few in number and kind, and include part of, kind of, and similar links. In automated ontologies, the links are computed vectors without explicit meaning. Various automated technologies are being developed to compute the meaning of words, latent semantic indexing and support vector machines, as well as natural language processing, artificial neural networks, and predicate calculus techniques. Ideesthesia is a psychological phenomenon in which activation of concepts evokes sensory experiences. For example, in synesthesia, activation of a concept of a letter, e.g., that of the letter is, evokes sensory-like experiences, e.g., of red color. Morphology in linguistics, morphology, per meter RFLD, is the study of words, how they are formed, and their relationship to other words in the same language. It analyzes the structure of words and parts of words, such as stems, root words, prefixes, and suffixes. Morphology also looks at parts of speech, intonation and stress, and the ways context can change a word's pronunciation and meaning. Morphology differs from morphological typology, which is the classification of languages based on their use of words, and lexicology, which is the study of words and how they make up a language's vocabulary. While words, along with clitics, are generally accepted as being the smallest units of syntax in most languages, if not all, many words can be related to other words by rules that collectively describe the grammar for that language. For example, English speakers recognize that the words dog and dogs are closely related, differentiated only by the plurality morpheme s, only found bound to noun phrases. Speakers of English, a fusional language, recognize these relations from their innate knowledge of English's rules of word formation. They infer intuitively that dog is to dogs as cat is to cats, and, in similar fashion, dog is to dog catcher as dish is to dishwasher. By contrast, classical Chinese has very little morphology, using almost exclusively unbound morphemes, free morphemes, and depending on word order to convey meaning. Most words in modern Standard Chinese, however, are compounds and most roots are bound. These are understood as grammars that represent the morphology of the language. The rules understood by a speaker reflect specific patterns or regularities in the way words are formed from smaller units in the language they are using, and how those smaller units interact in speech. In this way, morphology is the branch of linguistics that studies patterns of word formation within and across languages and attempts to formulate rules that model the knowledge of the speakers of those languages. Phonological and orthographic modifications between a base word and its origin may be partial to literacy skills. Studies have indicated that the presence of modification in phonology and orthography makes morphologically complex words harder to understand, and that the absence of modification between a base word and its origin makes morphologically complex words easier to understand. Morphologically complex words are easier to comprehend when they include a base word. Polysynthetic languages, such as Chukchi, have words composed of many morphemes. The Chukchi word Tamilp gamma trakin, for example, meaning I have a fierce headache, is composed of 8 morphemes t, may, lev p gamma t arkin, that may be glossed. The morphology of such languages allows for each consonant and vowel to be understood as morphemes, while the grammar of the language indicates the usage and understanding of each morpheme. The discipline that deals specifically with the sound changes occurring within morphemes is morphophonology. History of morphological analysis dates back to the ancient Indian linguist Panini, who formulated the 3,959 rules of Sanskrit morphology.